All right, we're going to continue our lesson with functions, and so now we're going to look at what if you have a set of points or ordered pairs and what's also called a mapping diagram. So there's a couple different ways that we can determine what is a function. So in case you forgot, a function is when a x or an input value is matched to one and only one y value. So again, if all of the x values, a set of points is very similar to a table. In fact, you can create the table to make your job easier. So if you want to create a list of ordered pairs or take those ordered pairs and take to a table, you can go either way. If all the x values are different, right away, if all the x values are different, then you're going to know that it is a function. Okay? Again, a lot of times students want to say that the x values can't repeat. Technically, they can repeat as long as it's matched to the same y value. So if any of the x values repeat, then it is not a function. But again, that little important side note, I'm going to make a little message right here. The x values can repeat if and only if the y value is the same. So an example for that, let's say that when x was x and then y, if we had x was 2 and y was 5, if they listed again, this is technically okay. That's a function because your x is repeated, but it's still matched to one and only one y value of that 5. So if they repeat, if and only if the y value is the same, then you're good to go. Okay? So what we want to look at, in case you forgot, x first and then y, when we do ordered pairs, and x is horizontal, left to right, and y is vertical, up and down. We only need to look at the x values. So I'm going to circle all the x values in that first set of ordered pairs. Remember those little squiggly lines? They look like parentheses in a bracket kind of pushed together. That just means for your set of numbers. So your ordered pairs are 0, 2, 1, 3, 3, 4, and 7, 5. So 0, 1, 3, and 7. If those are my x values, do any of those repeat? Nope, they're all different. So that means that this set of ordered pairs represents a function. Okay, so now we have a set of numbers. My ordered pairs are 1, 2, 1, 8, 1, 5, 3, 9. So if we look, our x values right here, 1, 1, 1, and 3. Well, 1, 1, and 1 are all the same, and they're matched to different y values. And therefore, because your x is matched to different y values, this is going to be not a function. If this were 1, 2, 1, 2, 1, 2, it would have been a function. If this was 1, 8, 1, 8, 1, 8, that would have been a function. If it was 1, 5, 1, 5, 1, 5, because those y values were the same, then that would be my kind of other opportunity for it. So that's what we need to think about. Okay? All right, let's look at the next one. Our ordered pairs are 1, 2, 3, 2, 5, 2, 7, 2. 1, 3, 5, and 7 are my x values. All of those numbers are different, so it is a function. What tricks people on this is they look at the y values, and they're all the same, but remember, it doesn't matter about the y values. The y values can repeat and be with different x values. The x values cannot repeat with different y values. So that's where you got to only think about looking at just those x's. All right, so let's look at this last one. X is 1, y is 2. X is 2, y is 3. X is 3, y is 4. X is 4, y is 5. So 1, 2, 3, and 4, those are all different numbers, so it is a function. All right, let's keep going. So now we're going to be looking at what's called a mapping diagram. So basically what a mapping diagram is going to look like, it's going to have two ovals, and we're going to match the group on the left to the group on the right. So we're always going to look at the ones on the left first. So if we look at the left, these are kind of like your input values or your X, and these are going to be your output values or your Y. Unless otherwise noted, unless for some reason they say this is Y and this is X, that would be the only thing that could change it up. But other than that, we're always going to read our diagrams like this, from left to right. So I'm just going to label these input, like my X, and output as my Y. Okay? So if all these values on the left point to only one number in the group on the right, then it is a function. If any of these values point to multiple numbers that are different in the grouping on the right, then it is not a function. But just like we talked about with the tables and the ordered pairs, if you had a number on the left and a number on the right, but the one on the right repeated but was the same number, that's going to be a little bit different. So let's see, if we had -2, 0, and 3, and then we had 7, 9, and 16, if the -2 is pointing to the 7, the 0 is pointing to the 9, and the 3 is pointing to the 16. All of these X values are different, and none of them are repeating, being repeating like -2 to 7 and -2 to 9. So therefore, this is a function. So again, you can think about this as like ordered pairs, or make a table if it makes it a little bit easier for you. All right, well, if I have 1, 3, 4, and 5, none of my values repeat. Well, let's see what happens over here. If I have 6, -3, and -2. If I have 1 to 6, that's like my ordered pair 1, 6. If I have 3 to -3, and then if I had 4 to -3 and 5 to -2. Even though this -3 is being used with the 3 and the 4, remember the Y values can repeat, be used more than once with the X's. The X values can't repeat and be used with different Y values. So that's okay the way that this is. Okay, so this one is going to be a function. And then my last one, if I had 5, 7, and 8, and then I had 1, 2, 3, and 4 as my Y values or my output, if I had 5 pointing to 1, 7 pointing to 2, 8 pointing to 3, and 8 pointing to 4. Well, my X values don't look like they repeat, but actually, right here, 8 is pointing to 3, and 8 is pointing to 4. So my X's would repeat if I made a list of ordered pairs, so this is not a function. Okay, the 8 is pointing to 2 different Y values. So when we're looking at a mapping diagram, sometimes your brain might play a trick on you. So what I would suggest doing is making a list of ordered pairs. So like on this one, it was 5 pointing to 1, 7 pointing to 2, 8 pointing to 3, and 8 pointing to 4. And we can see right here my X values repeat to different Y values. So over here on this one, we would say 1, 6, 3, -3, 4, -3, and 5, -2. See, none of those X values repeat. So with a mapping diagram, it can take just a little bit of time, just a little bit, just to make a list of ordered pairs, but just to make sure you're right. So basically, your numbers on the left can point to only one number on the right. And right here, because this 8 on the left was pointing to 2 numbers on the right, that's why it's not a function. So again, list those ordered pairs if it helps your brain out. Okay, in the next video, we're going to look at how we can identify functions from a graph.